JC Spartans, what it is, Precal 12. Hope you're doing well. 7:30, actually 7:31. And you're at Coach Jay's house. We're about ready to get it rolling here. Hopefully you found the link, and hopefully it is happening pretty good right now. I'm hoping that everything's smooth. If for some reason it's not today, please make sure you text me, 770-757-2240, and we'll see if I can help you however I can, well, with any questions you have there. Right now I'm going to go straight to review. So while you join, you can throw out any questions you want. And if there are no questions, then what I'll do is I'll end up, well, I'll go through some random questions that I think might be on the list, and we'll hit on more of them tomorrow. All right? All righty. Let me see here. You can see that. Perfect. Now I'm going to end up trying to pull up the review here. And while I'm pulling up the review, hope you had a great day today. Hope everything was just peachy for you. Peachy keen. Saw practices were good. I know soccer and baseball and lacrosse and all those. I'm sure you enjoyed weather all today. Hopefully it can on that for you. So I'm going to go to chapter 2 here. I'm right straight to the hike. You can find well you're on there. Remember that homeworks are due tomorrow. That's important. Homework's due tomorrow. Just kind of a reminder there. One. About ready to pull that up here. All right. All right, perfect. Just buying time. I should have had this up earlier, but it's my bad. All right, perfect. All right, so what we're going to do is this. We're going to go through just a couple of problems here, making sure that we're clear on what's expected of us, and we'll go through that together. Some of the word problems might be ones that we'll do kind of later on in class, just so that if I had any other questions, I could hit on those. Other than that, I'm going to start on number 2, and then we'll kind of roll from there, right? Number 2 says find two quadratics where the two zeros are -4, 0, 5, 0. Now, remember when we have steps or our zeros, the important thing to note that it's like we're working backwards. So if we had something in standard form, standard form is a, b, x plus c, we could find the x-intercepts by factoring it and then setting them equal to 0 and solving for what x equals, for what the x-intercepts are, just like that up here. So backwards. So we're saying -4, 0, and 5, 0. What is the quadratic in standard? In this, what we're to as a linear factor, right? We're going to have this quadratic as linear factors, where one will be +4 and one will be -5. So because I set both of those equal to 0, we know one is -4 and one is 5. So we have both of those there, and we've got them. We got everything set up there. X equals -4 and 5. So we're going to distribute this to get it in standard form to get x squared plus 4x minus 5x minus 20. Now, as I distribute and add together, you'll notice that it now is x squared minus x minus 20, to where now that would be my first quadratic. Now, if I came up with another quadratic, I would have a negative now on the outside, which would be negative parentheses x squared minus x minus 20, which I could leave or I could distribute depending upon what floats your boat there. But that's all I question number 2, and that's all I would be looking for that problem. Another one that I saw was that might throw people off is just making sure that you know how to do the end. All right, formulas that are important. So knowing that if it's even and it's positive, both go up, right? Even, positive, go up. Odd, or even and negative, both will go down. If it's odd and positive, will rise to the right, fall to the left. And if it's odd and negative, will rise to the left and fall to the right. So just again, hopefully a little bit of a reminder there that might be helpful you that mark, but that is something else that I saw too was one where it says list all the possible zeros. All to get this negative 4x to the fifth, right? And then it had all this, and then it had on the outside. Use the rational growth test to be able to solve for the possible zeros at P over Q, right? P over Q. So possible zeros are, first we know 25 is our P, right? Where Q is negative. So if it were to now come up with the factors of 25, I would have plus or minus 1, plus or minus 5, and plus or minus 25. And I would do that on the top. Well, the bottom, I'd have plus or 1, plus or minus 2, and plus or minus 4. Now, I've set it up appropriately, but everything I need here now is in terms of each individual number. So I need 1 over 1, 5 over 1, 25 over 1. Same thing for 2 and same thing for 4. So my answers will be 1, 5, 25. That's easy, right? But then we have 1 over 2, so we'll have 1/2, plus or minus 1/2. 5 over 2, plus or minus 5/2. 25 over 2, plus or minus 25 over 2 here. 1 over 4, plus or minus 1 over 4. Plus or minus 5 over 4. Right here, 5 over 4. And plus or minus 25 over 4. And those are all of the rational zeros that could possibly be a zero within this polynomial. And again, notice it did not say to actually put them in. It just said list the possibilities. So again, that's all we're looking at there. Synthetic division, I don't think we had an issue on. One thing that I did notice was that there was one that said there's a degree polynomial of 4. Meaning exponent is 4. It also has a 0, 0, and 2. So -3, 0, and 2, but 2 with multiplicity of 2 twice. So as I look at this within linear factors, we have x plus 3 for the first one. Because 0, we'll have an x on the side. Because we have 2 2's, we'll then put x minus 2 squared, or you could just put 2x minus 2's to be able to get that there. Now, if I were to say, or you could put this as a function, f of x is what we normally use it. If I said put this in terms of a linear factor, you've already done that. But if I said to distribute this, what we would do now is multiply x times x plus 3 to get x squared plus 3x. So we've done that first part there. Now, x minus 2 times x minus 2, we would distribute to get x squared minus 4x plus 4 there. And again, you could do it the long way. I can kind of do it in my head, so I did it that way. But again, depends on what you're looking for there, kind of what we would get. So now we'd have x squared times x squared to get x to the 4th, x squared times negative 4x to get negative 4x to the 3rd, x squared times 4x squared. Yeah, 3x times x squared is 3x squared. 3x times negative 4 is negative 12x squared. X times 4, 12x. So now let's add like terms together to get x to the 4th minus x. This should be x to the 3rd. Sorry about that. Minus squared. This is sure we go through it in that way. But as I multiplied it together, my function in terms of standard form would be that, well, what you a good one to look at and see would be another one good for the test there. All right. Is another good. If you look at that one, that one's the one with the John Deere where you plug in 200,100 in for revenue. Let's look at that. Right? Go back here. All right, so we have 200,100 in for my revenue equals 1/2 p squared plus 1,900. I think negative, but plus 1,900 p. So on this one, man, this does get kind of what they're looking for is what is P going, what's the unit price when the revenue is 200,100? So we want to get this equal to 0, because if we get it equal to 0, we can solve for 0. P is 200,100. So we get 0 equals negative 1/2 P squared plus 1900 P minus 200,100. So that's what we would get there when we would solve for it, and we would actually plug that into our calculator. And when we plug that into our calculator, we'll find what the zeros are and what the solutions would be there. So I would have negative 1/2 x plus 900 x and minus 200,100. Okay, so I plug that in. Once I can zoom a little bit, kind of big here, isn't it? Yeah, it's way big. So you may have to do like kind of know there, but as you look at it, kind of see that the unit price for that revenue could be at 2 possible locations. It could be at 108.41. Okay, and as you look backwards, and I think this might actually be outside of it, it also has 3,691.60 as my answer as well. Well, if we look at just our unit price, if we're thinking of something that makes sense, right? The problem talks about heavy-duty tractors, right? A unit price P in dollars that it charges. If the revenue is, and then it gives it, what is the unit price that is associated with a revenue of that specific value. And so what I would say is the revenue or the unit price would be $108.41, because that's what we're looking for in terms of that P is concerned. And this other, it really kind of goes outside of what we're looking for. We're looking for unit price. If you think of unit price, we would be talking about $108.41. All right? All right. So on that one, again, that's kind of another good one that we kind of just want to make sure we understand and look at that one again in class a little bit more. But, again, that was a little bit challenging and one that's good for us to do there. All right? All right. Keep going. Next one on number 7. Number 7 is one where we use synthetic division. Once we do in with synthetic division, we'll determine, or we should get a remainder of 0, and then we can use number 7 to factor and go there. Number 8. Number 8 is another tough one. And because I think those other ones I think will be okay on. If you're watching right now and need more help, throw it out. I'd love to go over that with you if you needed me to. All right. V of x equals x times 23 2x squared, I believe. Let me make sure. Let me make sure on that. 23 minus 2x. Perfect. Now it asks for a couple. Number 1. Number 2 at the maximum. So where the volume is a maximum, they want the x value. Okay? And also want the maximum volume, which would be the y. Okay? So as we solve for the maximum value of y, or y is the same thing as v of x, right? Okay? Now if I were to look at these 3 values, right? These 3 values, no, is I really want to first think about this problem. Because if you think about a box, right? A box that has this box. Well, what it would do is it would fold at the perforated edges, right? It should make sense. Well, this represents what this X is, or the cut that is within this box. So again, we're trying to look at that volume there. So if you think about this value in, I'm going to plug in x times 23 minus 2x and get for the graph. So I'm going to go, again, you kind of go zoom fit there and then back it up just a hair. And that may not work, so I'm going to go zoom standard. That didn't really work for me. And as I look at zoom standard and I back it up just a little bit, the graph looks something like this. It goes up, touches, comes back down, touches, and then returns. So if you think about a graph here, what we're trying to look for is a couple things. We're trying to look for, what is the domain? Well, remember that the volume is the y. So anything where the volume is negative or where it goes to infinity, we know that that is outside of our domain. The only domain that we could have is from 0 to what this place is here, or this minimum. So if I decided to solve for that minimum, I realize that the minimum is 11.5 comma 0. That's the minimum. So what I have now is a domain that can be between 0 and 11.5. So I can say that x is in between 11.5 and 0, where x is greater than 0, but then it is also less than 11.5. So I know that that's the case, so I'm going to leave that domain here. Now, in my maximum, I can go to my maximum by going here and going left bound, right bound, and then guess. And I note that my maximum is at 3.83, comma 901.26. So because of that, what that means, the maximum value I can have, my maximum volume would be at 901.26 when the was 0.3, or right there at 3.83. So that's important to note that my volume is maximized. I cut it at 3.83. The way that I can use this calculator to solve for that specific problem there. Okay? All right. Any text here, but there's one viewer, so I want to make sure I continue just a little bit longer here. Let's see. Keep going. End behavior on 10, we're good on. Long division we'll do in class. I want to do number 12, 13. I think all the imaginary stuff we're good on. So let's do this. Let's finish off with 3 problems. Let's do numbers 9, 12, and 13. So I'll put down, I think those ones we really walk through together. So we have negative 3x squared plus 9x minus 7. That's right. The next one, number 12, x-intercepts and y-intercepts. Okay. So this give x, give 4, x plus 3 squared plus 5. Awesome. So I need x, y-intercepts, x, and y-intercepts. It needs to be put in a vertex form up here. So we're gonna do all that in a second. And the last one is to invert as well. Okay. Put it in the vertex form as well. And this one has it as number 12, 2/7 or negative 2/7. Minus 21, I'm sorry. All right. Now, in order to know all of this, we have to know the 2 forms. First of all, we have our standard form compared to our vertex form. If you really want the kind of traditional form, the traditional form would be this: x minus h squared with the a on the outside and plus k, whereas standard form would be ax squared plus bx plus c. All right? So when I solve for this, the important thing to note is I can find my y-intercept by plugging 0 in for x. So I'd have 0 plus 0 minus 7, where my y-intercept would be 0, negative 7, and that's that. Now, that's not very difficult. Not hard at all, but again, that's a way that we can do that there. Another way to find our x-intercepts, you could do ones we could factor and equal to 0. Number 2, you can solve using the quadratic formula. Or number 3, you could do the you could plug it in your graph and solve for the x-intercepts that way as well. Whatever floats your boat, it's completely up to you. But as I look at this, it's going to be hard to factor. So I'm going to go on my graphing calculator and do it that way, but you could do it a completely different way as well. All right, so negative 3x squared plus 9x minus 7. So we're going to graph right there. And when we graph it, the x-intercept that I see here, actually, I'm trying to see. I think I might have messed up. Let me see here. Negative 3x squared plus 9x minus 7. They may not get there. Let me see here. Make sure here, negative, perfect. As I here, actually, just make 100% sure, negative 3x squared plus x minus 7. In fact, now I actually no vertex. Let me look at this one more time here. 9. Well, I'm sorry, not no vertex. There's no x-intercepts. And if I look at it here, there are intercepts. Puts no x-intercepts. So you would be good to go right there. That's what threw me off. We have vertex, right? We have negative 9 over 2a, which a is negative 3. So when plugged in, we have negative 9 over 2 times negative 3, which would be negative 9 over negative 6, or we could say 3/2, right? That would be the x. Now, as far as the y is concerned, we could plug 3/2 in for x to get negative 3 times 3 squared times 3 is 7. So as I distribute here, I get 27 over 2. This would be 94, so negative over 4. So we're going to add that together. So I'm going to multiply everything on the bottom by, we get 4, 54, this would be 4. So as I simplify here, I end up getting negative 55 plus 54, negative 1/4 as my y within my vertex. So what could I do with this in order to solve for my answer back here and say, what is a? Well, a in standard form is the same as a is in vertex form. So I get negative 3 times x minus 3/2 because the first value. And then I just subtract 1/4 on the outside, and that's in vertex form with my y-intercept as my vertex up. Now my next part is a little bit different. On this one, I want to find x and y. But first I got to distribute plus 3 squared. So when I do that, I get x squared plus 6x plus 9, but I'm going to multiply that by negative 4. 4x squared, 24x, minus 36, and I know plus 5 would end up being negative 31 as my simplified answer. So this is what I should have right here. Now, I'm not quite done yet because I've pretty much just set this up in standard form to solve for what my x and y intercepts are. Y, I'm going to throw in for x. And when I do that, I get negative 31 out, so I have 0, negative 31. Now, my x-intercepts solve. I don't think I can factor this and plug it into my graphing calculator. And the ones where you can't use your graph calculator on will be easier than this to factor. You'll be able to kind of get it out a little bit easier than what we're doing here. So when we graph it, we have two solutions. 4.1, comma 0, right? And the second one being negative 1.88, comma 0. And again, there's my y and x for that problem. All right? For this one, number 13, I'm going to hold off on that one till the class. But if you have any, we can put a class together. The big thing is understanding the pattern and formula for it, taking it very slow, and understanding 0. We plug 0 in for x when we solve for y-intercept, and 0 for y when we solve for x-intercept. And then we go from there. Hey, I hope this was helpful for you. I know I didn't get any text, but I have a couple viewers there. Hopefully this was helpful for you. If you have any more questions, bring them to class tomorrow, and I'd love to look at them with you later. Thank you. Hope you have a great day. Bye now.